Welcome to section 1.1. In this section, we're mostly going to talk about and define different kinds of numbers. So as you can see, I have a list here of different kinds of numbers, and we're going to talk about what each kind is. So let's start with counting numbers. If I asked you to count something, you would most likely start by going 1, 2, 3, 4, so on and so forth. Now, of course, you might count by tens or hundreds or something like that too, but for the most part, if we're counting stuff, we go 1, 2, 3, 4, 5, and those are called the counting numbers. So 1, 2, 3, 4, and then I put dot, dot, dot like that, dot, 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 just indicates that that list goes on and on forever. So those are the counting numbers. For the whole numbers, I throw in one more number. I throw in the number 0. So the whole numbers are 0, 1, 2, 3, 4, dot, dot, dot. And those are known as the whole numbers. So the whole numbers are just the counting numbers plus the number 0. For integers, I throw in all the negatives of the whole numbers. So we might write dot, 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 -4, -3, -2, -1, 0, 1, 2, 3, 4, dot, dot, dot. So again, the dot, dot, dot means this goes forever in both directions. So you get numbers like -36 million. You get positive numbers like 14,283, so on and so forth. Those are called the integers. So again, the counting numbers are 1, 2, 3, 4. Whole numbers, we throw in the number 0. For the integers, we throw in the negative whole numbers. So we get our whole numbers, and then we have all the negatives. All right, then it starts to get a little bit harder. The rational numbers. These are fractions of integers. Little rule though, bottom can't be 0. You can never have 0 on the bottom of a fraction. So rational numbers could be things like 2/3 or -8/5. It's a fraction of integers. So I have an integer on top, I have an integer on bottom. As long as I don't have 0 down on bottom, I'm okay. Now, here's a fun fact. 6. 6 is actually a rational number. More importantly, it's a counting number and a whole number and an integer. Those are all true statements too, but it is a rational number because I can write 6 as 6/1. And of course, I can do that with any integer. So any integer is also a rational number. I could take -26 and I could tell you that's the same as -26/1. So all of the integers are also rational numbers, but notice the other way is not true. Not all rational numbers are integers. For example, 2/3 is a rational number, but 2/3 is not an integer. Now, there's another way to describe rational numbers. So I should have left myself more space here, but I didn't. That's okay, I'll write over here. The other way to describe rational numbers are decimals that repeat or terminate. So what I mean by that is, slide that over so you can see it. 2/3, you might know what that is as a decimal. That's 0.6666, and it goes on and on and on forever, which you may write sometimes as 0.6 with a bar over it. So this would be what we call a repeating decimal. The 6 repeats over and over and over again. Or you might have something like 0.525252 dot dot dot, which we sometimes write as 0.52 with a bar over the 5 and the 2. That's also a repeating decimal. The 5 and the 2 are repeating. On the other hand, this one, -8, negative 8/5 happens to be negative 1.6. This would be a decimal that we say terminates. It ends, it stops. That's all terminate means. So those are the two ways you can talk about rational numbers. You can talk about rational numbers as fractions, or you can talk about them as decimals. All right, that makes the next one easier to describe. Irrational numbers, these are numbers that are not rational. All right, so a little hard to describe in terms of fractions. An irrational number is a number that cannot be written as a fraction of integers. Okay, well, it's a true statement. Kind of hard to tell you what they really are, though. So a better one is irrational numbers. These are decimals that neither terminate nor repeat. And the most famous one, probably that everybody knows, is the number pi. Pi, if you grab your calculator here and you type in pi. Now, of course, on the calculator, it terminates because the calculator can only give us so many decimal places. But you'll notice that this doesn't look to be a number that's repeating. 3.141592654. It doesn't look like there's a block repeating anywhere. Now, hard to convince you that there isn't one, but you'll just have to believe me when I tell you that pi is an irrational number. Other irrational numbers that you may be familiar with are most of the square roots, like square root of 2, square root of 3. Those are both irrational. Square root of 4, you get a little issue there. Square root of 4 is a nice number. Square root of 4 is 2, so that would fall back into the rationals. But let's take a look at square root of 2, for example. Again, you see a string of numbers here. It doesn't look like it's repeating. And again, it terminates only because of the limitations of the calculator. Same deal with square root of 3. And square root of 3 is a little bit misleading on the calculator because it looks like maybe it's repeating eventually here. We see 0808. If I had an instrument which could give me more decimal places, however, we would see that that pattern does not continue. All right, let me give you one more irrational number, one that I can completely convince you does not end and does not repeat. Harder to do it with these numbers here. All right, so I'm going to make one up here. It's going to be 0.53. 553. 5553. That's a 3. 555. Oh, it looks like I messed up my number. Let me try that again. 0.53. 553. 5553. 4 5s and a 3. Dot, dot, dot. So this is an irrational number, but it's one that I like because it has a pattern at least. You can see what's going on. But you can see, because I put dot, 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 it never ends. And you can see by following the pattern, it's not repeating because each time I'm adding one extra 5. So there's an irrational number that has a pattern to it, but certainly fits the category that it's not terminating and it's not repeating. Okay, our last two kinds of numbers. Real numbers. All of the above. So real numbers are counting numbers, whole numbers, integers, rationals, and irrational numbers. So those are all known as the real numbers. And then we have something called imaginary numbers. Imaginary numbers come out of square roots, such as the square root of -9. Now, a lot of people, when they first see this, they say the square root of -9 should be -3. But that's not right, because if I take -3 and I square it, that's -3 times -3. When I multiply two negatives, I get a positive, I get 9. So There isn't a real number, none of these kind of numbers up here, that I can square and end up getting the number -9 back. So that makes this an imaginary number. So imaginary numbers, we're not going to deal much with imaginary numbers in this class, so you don't have to worry about them a whole lot, but they'll show up in your book. Basically, you're going to have imaginary numbers when you have negatives under a square root. Okay, I'm going to leave this page for a minute and go to this one. Write each number in the correct location on the Venn diagram of the real number system. Each number should be written only once. All right, so I want to write the numbers where they go, but I want to write them in the most accurate location. For example, I could write all of these numbers over here. They're all real numbers, but that's not really what I want to do. So I want to start with like -6. -6 is a rational number. That's true, because it can be written as a fraction, -6/1. It's also an integer, if you remember our integers. Integers have the negatives, so I could put it in this circle, but it's not a whole number. The whole numbers only have positives. So -6, I would put in that spot. That's the most detailed information I can give about -6. All right, 2.73. That's a decimal that terminates. So that means that one's rational. 2.73. Decimal that terminates. Square root of 3/7. 3/7. That's a fraction of integers. So that one's also rational. Goes in that spot. Square root of 2. We talked about square root of 2. That's a decimal that doesn't repeat, doesn't terminate. So that one would go over there. Irrational. Where on the other hand, square root of 9 is a fancy way of writing the number 3. So the number 3 is rational. It's a fraction. It's also an integer, but more specifically, it's a whole number. Square root of 9 is the number 3. All right, -100. -100, that is rational, but more specifically, it's an integer. Okay, I'm going to pause this video because I'm running into time limits on the software that I'm using. So I'm going to pause this video, and then we will continue, and I'll make a second video, and then I'll just have to merge them together. You won't know that there's really two videos, except for the fact that I'm telling you.